Jai Hind everyone. I am Vivek Kumar Pansari, Assistant Professor in Department of Mechanical Engineering at Ajay Kumar Garg Engineering College, Ghaziabad. In the lecture series of Fundamentals of Mechanical Engineering, which is a first year course, BME 101 in first semester and BME 201 in second semester. In the lecture series of this particular subject, I am trying to cover some important topics and questions which are frequently asked in exam, because many times my own students has asked, sir, I want some discussion or your comments on the answers, how to write. So, for that purpose, I tried to compile all the questions from previous year papers and their probable solution, how to write, not exactly the answer, but in which manner you are supposed to write. So, here you can find out that on unit 1 there are certain questions over there marked here, the marks, for how much marks these questions have been asked and in which year these questions were there, the part of the question paper of BME 101 and 201. So, the first question which you are observing, that it is a theoretical question, Hooke's law, state Hooke's law. So, what basically the Hooke's law is? It is well known. The Robert Hooke, an English mathematician, conducted several experiments and concluded that within the elastic limit, stress is directly proportional to strain. So, the very first question which we are observing here, that is state Hooke's law. So, Hooke's law, it is given by Robert Hooke, an English mathematician who has conducted several experiments. On the basis of his experiments, he concluded that within the elastic limit, the stress induced in a body is directly proportional to strain. What is the meaning of elastic limit? Elastic limit means the maximum value of stress up to which material will be able to recover its shape and size after removal of the deforming force. So, this is what the meaning, and this is important because this particular law is valid only up to this point, and obviously when a material is subjected to some deforming force, some resistance will be offered by material which will induce the stress, and in that limit stress is directly proportional to strain. Stress we normally denote with the help of sigma, and epsilon is the denotation for the strain. So, sigma is directly proportional to epsilon. By removing the proportionality sign, you will be finding the elastic constant, which is modulus of elasticity here. So, sigma equal to E epsilon that. Along with that, if this is the question for 2 marks, you are supposed to draw the stress strain diagram within the elastic range. Okay. So, this is the answer for that particular question. Sometimes this question is also combined with the right assumptions which are taken by Hooke for defining this law. So, assumptions are these: material is linearly elastic, so elasticity we have already explained, and material is homogeneous. Homogeneous means it is showing the uniform properties, uniform thickness, uniform distribution of mass, uniform density throughout its length. So, this is what you are supposed to answer when you are going for writing the Hooke's law. The second question which is asked over there, that is the principle of superposition and principle of force transmissibility. You may be finding here, that is the principle of force transmissibility and principle of superposition. Okay. Principle of superposition. Many times students are writing that superposition in terms of the interference, in terms of the algebraic sum of all the displacements. So, okay, it is related to that, but we are here discussing in the context of elongation of bar. So we have to write our answer in that particular manner. So principle of superposition in the context of elongation of bar. So what I am writing here, according to this, the net elongation of bar of varying cross section. Varying cross section, if I say, so let me draw a bar of varying cross section. So this is a bar of varying cross section. It is subjected to various loads P1, P2, P3, P4. The lengths of this section L1, L2, L3, their cross sections A1, A2, A3. So the net elongation in this bar, which is subjected to various loads in various cross section. So the algebraic sum of elongation in individual sections. Net elongation will be the sum of algebraic sum of elongations in individual sections. Individual sections means this is the section 1, this is the section 2, this is the section 3. So elongation in section 1, elongation in section 2, elongation in section 3 because of P1, P2, P3, P4. So what I will be writing, delta L, that is the net elongation in the entire bar L1 plus L2 plus L3, that will be equal to delta L1 plus minus delta L2 plus minus delta L3. Why I am using plus minus? Because sometimes it may be contraction also in some part of the bar. So I will be writing. So principle of superposition you have to write in this manner. Don't write delta y equal to delta y1 plus minus delta y2, although those both the things are similar in nature, but our context here is different. So principle of superposition, I hope it is quite clear. Another very frequently asked question is principle of force transmissibility. Principle of force transmissibility. Okay. So in a rigid body, a force can be transmitted to any point in its line of action. Its effect will remain same on the body. So if it is a 2-mark question, then you are supposed to write this statement, and along with that draw a rigid body. This body must be nature of rigid. If a force F is there, then according to this principle, this force can be transmitted at any point in its line of action. So now it has been transmitted from A to B. So whatever the effect is created by force F when it is at point A, the same effect will be produced by the force F when it is transmitted at point B. So this is what the principle of force transmissibility. Again I am repeating, in a rigid body, a force can be transmitted to any point in its line of action. Its effect will remain same. Limitations क्या हैं? Limitations clearly written. Already these are covered in the statement also. But again I am specifying, body must be rigid. If body is deformable, then definitely the effects will be different. And the line of action must be same. The force will be transmitted in the same line. Okay. So I hope now the 3 things are clear. 3 statements: Hooke's law, principle of superposition, principle of force transmissibility. Now I am moving towards the another part, elastic constant. In the very first statement, Hooke's law, we discussed that stress is directly proportional to strain, and by removing the proportionality sign, we find the elastic constant. So we deal with the various elastic constant. The first one, that is the modulus of elasticity. Second, modulus of rigidity. The third, that is K, modulus, bulk modulus. Okay. So modulus of elasticity, this is also asked in exam. We discussed different elastic constant or different modulus of elasticity. Okay, modulus of elasticity, somewhere it can be written as Young's modulus also. So it has been defined as the ratio of normal stress to longitudinal strain within the elastic limit. What does it mean? Suppose this is a body, this is subjected to force P, its length is L, cross section is A. So the stress, what will be the nature of stress? Normal stress, because the resistive force will be perpendicular to the plane of application. So normally we denote with sigma. Okay, so this sigma, and strain, because of this deforming force, there is a possibility of change in length in the direction of force applied along the length. So the strain will be known as longitudinal strain. Why I am writing longitudinal strain? Because the elongation or contraction is in the direction of force applied or along the length. So that's why I am writing is, so that I can write epsilon L, longitudinal strain. What I will be writing? Delta L upon L. And according to Hooke's law, sigma is directly proportional to epsilon L. When removes the proportionality sign, then we came across a modulus of elasticity, epsilon L. So E equals to what? It is the ratio of normal stress to longitudinal strain and within the elastic limit, because our law is valid for, Hooke's law is valid up to the elastic limit. The second modulus is the modulus of rigidity, and rigidity, that term is related to the shape and size of the body. So what is written over there? It is defined as the ratio of shearing stress. If I am saying shearing stress, then the deforming force and the resistive force induced in a body that will be tangential or parallel to the plane of application. So that is the shearing. Shearing means tangential or parallel. So so when I talk about this, then suppose this body is subjected to some force which is parallel to the plane of application. Because of this, there is change in shape. So that is the shear strain. This phi is shear strain, and this force P is causing shearing stress in the plane of this body. So the ratio of shearing stress to shearing strain, that term is known as modulus of rigidity. So when the deforming force or the resistive force offered by a body is parallel to the plane of application, then we talk about the term shearing stress, and the ratio of shearing stress, which is denoted by Q here, with the shearing strain phi, that is what known as modulus of rigidity. So I hope this term is also clear. Now I am moving towards another term, another elastic constant, that is bulk modulus. Bulk. This particular term, bulk, means it is related to the size of the body. It is related to the volume of the body. So many times we are observing that there occurs the change in volume. Change in volume. In which condition? Let me draw one case. Suppose this is a very small stress element which is subjected to normal stresses. Normal stresses, if I am saying, so obviously these stresses are perpendicular. So now if I say a stress element or a body is subjected to equal and like stresses on all its faces. Suppose this is the body and on all its plane the stress is sigma. So what will happen? What will be observing? We will be observing the change in volume. Just take the example of tire getting filled with the air. What change we normally observe? We normally observe the change in volume. So that change in volume with respect to original volume, that term is known as volumetric strain. Okay, that's what the strain is. Change in volume, how much change is occurring because of the sigma stresses on all its face. So that is the delta V, change in volume, and with respect to original volume, that is the volumetric strain. Now apply the Hooke's law. Stress of which nature? Stress is of nature of normal. So normal stress divided by volumetric strain, that is what known as bulk modulus. So that's what written over here. When a body is subjected to identical normal stresses on three mutually perpendicular directions, the body undergoes uniform changes in three directions without undergoing distortion of shape. So the ratio of change in volume to original volume is known as volumetric strain, and the bulk modulus is defined as the ratio of normal stress to volumetric strain. So these are the different elastic constants I tried to cover in this particular section. What are these? Modulus of elasticity means Young's modulus, then modulus, bulk modulus, and modulus of rigidity, E, K and G. Somewhere you may find in place of G, C also. So this is what the bulk modulus. Now I am coming to the another important question or statement that is again and again asked in exam, Poisson's ratio. Okay, Poisson's ratio. So let me explain first what basically we are going to talk. If I say, if there is a deforming force which is causing the change in length of this body, change in length for this body, okay, change in length. So if the volume is constant for this particular body, then obviously if length is increasing, so either the thickness or the width will be decreasing. Yes or no? Change in length, width, original length, that term is known as longitudinal strain, delta L upon L, because it is in the direction of force, it is along the length, which we have already discussed. So that is the longitudinal strain. But along with that, we are observing that either the thickness or the width is decreasing. Yes or no? So that is the lateral, because that is the strain occurring perpendicular to the direction of force applied. So that is what known as lateral strain. And the ratio of these two strains, lateral strain to the longitudinal strain within the elastic limit for a particular material, is a constant quantity, and that quantity is known as Poisson's ratio, which is normally shown with the help of 1 upon m. Somewhere you may find mu. So lateral strain upon longitudinal strain, and its value lies between 0 to 0.5. Here I have used minus sign, very clear to everyone. If length is increasing, then obviously either the width or thickness will be decreasing. So the nature of lateral strain will be opposite to the nature of longitudinal strain. So let me explain with a small diagram also. If I say this body is subjected, L is the length, D is the diameter, because of the force P, if I say the length is increased by delta L. So longitudinal strain will be how much? That will be delta L upon L. Along with that, we are also observing that there is the decrease in the thickness. If I say that decrease is delta D, so lateral strain will be how much? That is minus delta D upon D, and the ratio of these two quantities, lateral strain to longitudinal strain within the elastic limit, that is a constant which is known as Poisson's ratio. Okay, so and its value 0 to 0.5. Here you can observe, if the length is increasing, then the width or thickness or the diameter will be decreasing. That's why the negative sign has been taken. So this is what the Poisson's ratio. Again, I am repeating, the ratio of lateral to longitudinal strain for a material is a constant quantity which is known as Poisson's ratio. So here, if I go through the table which I have drawn here, Hooke's law I covered, the principle of superposition, Young's modulus, bulk modulus, Poisson's ratio, principle of force transmissibility, the lateral strain, longitudinal strain, volumetric strain. So these things I covered. In the next lecture, I will be covering many more points and the numericals also on that particular unit and topic. So thank you very much for watching the video. Thank you.